Hey, welcome back to Mr. PL's with Algebra 2. This is Unit 3, Topic 1, SLT number 4. And we are getting into characteristics of trig graphs. In the next topic, we're going to actually be graphing trig functions. And here, we're just going to get a little idea of like what the functions look like and what their characteristics are and why they are what they are. So we've been doing all these Ferris wheel questions and merry-go-round questions talking about the height at different positions. Well, as your height changes over time, you will, so at the starting position, you'll go up when you're talking about a Ferris wheel. So your height will increase. So kind of like this is the height right here. This number right there represents 30. So it looks like it's going by 2's for each box, 2, 4, 6, 8, and so forth. So it looks like the center height is going to be 30. And then as you rotate, you continually get higher until you get to the maximum height, which is right here at, it's kind of hard to say, let's say it's about 55. And the minimum height is down here, which looks to be about 5. So this will be the highest point you'll ever be on the Ferris wheel, and this will be the lowest point, which is over here. The height of the center from ground. So this height right here, which I'm putting a dotted line, represents the height of the center, which is where you started at, which I should be able to find the highest. It should be right in the middle of the highest point and the lowest point. So if I add these two and divide by 2, that equals 60. 60 divided by 2 is 30, which makes sense because it looks like it's starting right there at 30. And then the radius height would be the distance away from that center height. So when you think about a Ferris wheel, the highest point minus the center height is the radius. That is that distance. So 55 minus the center height equals 25. And the time it takes to complete one rotation, well, you go up to, so here's the starting position. That's right here. Here's after you've gone 90 degrees, which is the highest point. Then you come back to the same height, which is here. So if I call this location A, this is location B, and this is location C. Then this would be location D, which is at your lowest point. And then you come back up here to position A again. So that's the same height. So that means you completed one full cycle. So that takes 60 seconds. Now, the direction of the rider at start looks like it's going up. So from the start, it's going to go up. It's going the normal direction. Same kind of question. So maximum height, I'm just going to go a little bit quicker through this though. So this one's going by 1. So this is 29. The lowest point is right there, which looks like it's 7. The center height must be the difference of the two. So if I add those two heights and I divide by 2, that's 36. 36 divided by 2 is 18, which makes sense because that's where it's starting right there at 18. The radius, so if I make this dotted line right here, the radius height would be that difference. Or you could say it's this difference. It really doesn't matter which way you do it. So 29 minus the center height, which is 11. Or you could say the center height 18 minus 7 would equal that same distance as well. So this is 11 below this, and this is 11 above this. Time to complete one rotation. So as I mentioned before, using the A's, so this is position A, B, that's 90 degrees, that's 180, that's 270. Right here is when you get back to A again. So if you think about that circle, so A, B, C, D, back to A again, that's one complete cycle, which is 8 seconds. So don't just say, oh, here's the end of the graph. That must be the amount of time it takes to complete one rotation, because it's not. One rotation is down, up, back to the starting height, back to the highest point, then back to the starting height. So you should be at the same starting height 3 times over that one full rotation. And this time it was going down to begin with. Okay, I need to plug it in. Maximum height here is 18. Minimum height here is 2. So now keep in mind that this one's starting at the minimum height, whereas the last two questions were both starting at the midpoint, which I'm using terminology for future videos. This is a sine function, and this is a cosine function because it's not starting in the middle. It's starting at either the highest or the lowest. So the height of the center to the ground, center to the ground. So remember what we did before. So we add the 2 and divide by 2. That means it's 10. 10 is the middle of the graph. And the radius is 8, because 18 minus 10 is 8, or you can say 10 minus 2 is also 8. Time to complete one rotation, so that's 90, 180, 270, 360, 10 seconds. And it looks like the direction was going up, because at the start it was started at the very lowest point and it was going up. Maximum height, so the maximum height is 44. Minimum height, lowest point it ever goes, looks like it's 4. Add those two together and divide by 2. 48 divided by 2 is 40. 48 is 44. No. 44 plus 4 makes 48. Divided by 2 makes 24. So 24 is the center height. And the radius, 44 minus 24 equals 20. So this is 20 above this, and this is 20 below this. That makes sense. Time to complete one rotation. Okay, so this one's a little bit trickier than the last because we don't even have one complete rotation on our graph. So what I'm going to do is 180 degrees is halfway around, and that should take half the time. So I'm just going to double that time. So there's 90 degrees. So that's like going from to location A to location B, if you remember the circle. Although that's not technically, in this case, we're starting here at A. So it's just a little bit different. So then we go down to here to B, and then down here to C, and that's halfway around the circle. So that takes 10 seconds to go halfway around in the circle, which means it would take 20 seconds, or double that, to make it all the way around the circle. And this one was going down to begin with. So we started here to here to here to here. I mean, technically, you could have been going the other direction. We don't really know. Does not matter in the end. Maximum height, highest point is 34. Minimum height is 6. Add those two together, divide by 2, you get 20, because now 34 minus 20 is 14. So this is 14 above this, and this is 14 below this. That makes sense. All right, time to complete one rotation. So there's A, oh, I'm sorry, there's A, there's B, there's C, there's D, and then you're back to the same rotation. So this is like in your circle. So A, B, C, D, back to the same point. So that takes 32 seconds, and it's going down to begin with. All right, let me see. How many more do I got? Oh, I got a lot of these. All right, 3 more. Maximum height looks to be 10. Minimum height is 4. Height from center of the ground, add the 2 up. It's basically the same. I really could just stop after this one because I'm really doing the exact same thing every time. 14 divided by 2 is 7. The radius is the difference between, so 10 minus 7 is 3. That's 3 above it. That's 3 below it. And time to complete one rotation. So 90 degrees, 180, 270, 360. Looks like it's 20 seconds. And it's going up to begin with. They are quick, so I'll do the last two. So maximum height is 49. Minimum height is 5. Got to really look closely here. So add those two together and divide by 2. You get, let's see, 54 divided by 2 is 27. 49 minus 27 equals 22. So this is 22 below it, and this is 22 above it. And time to complete one rotation. So 90 degrees, 180, 270, 360. So it looks like it takes 4 seconds, and it's going up. Oh, okay. So I showed that. I pressed the wrong button. So there we go. Back to where we were. So 28 is the highest point. Lowest point is 8. Center height, add the 2 together, divide by 2. So that's 36. Divided by 2 is 18. 28 minus 18 is 10. That's 10 above, and that's 10 below. That makes sense. That means this is the center of these two numbers. 90 degrees, 180, 270, 360. This is also a cosine function because it's starting at the maximum height. And it's going to take 24 seconds to complete one rotation. And it does another rotation, and it does half of another rotation. And this one's going down to begin with. So is there one more? Let's see. Oh, no, that was the last one. So these I already had here. So now we're actually figuring out the heights using trigonometry. So we have the radius times sine of x, which represents the theta, which is the degree, and add that to the 14, which is the center height. And you can use that formula to find any equation. So this is actually that's the equation to this graph. So that's basically what you're seeing right here. And then on the next topic, we're actually going to be taking these equations and turning them into graphs. So that's kind of interesting. It shows you the exact opposite of what we'll be doing in the future. All right, thanks again for watching, and please give it a like to help you figure out how to either write an equation based on examples or how to figure out these characteristics of sine and cosine graphs. Thanks again for watching. Have a great day.